All right, you guys, I'm going to read out loud your review book assignment for days 9 and 10, pages 90 to 93, and I'm also going to underline important information and make some text annotations while I read. Heat, energy, and changes of state. Matter may exist in the solid, liquid, or gaseous states or phases. An increase or decrease in energy and temperature of matter can cause the matter to go from one state to another. Types of change or state. The following are some changes of state. Melting is the changing of a solid to a liquid. Solidification or freezing is the changing of liquid to a solid. If solidification results in a solid with an ordered pattern of atoms, the process is called crystallization. Evaporation or vaporization is the changing of a liquid to a gas or vapor. Condensation is the changing of a gas or a vapor to a liquid. Sublimation or sublimation is the changing of a gas directly to a solid, also called deposition, or from a solid directly to a gas without going through a liquid state. The changes in state of water are shown in figure 5.6. When water changes state from a solid to a liquid to a gas, it absorbs heat. Molecular movement speeds up, and the tightly bound water molecules become less and less tightly bound. When water changes state from a gas to a liquid to a solid, water releases stored heat. Molecular movements slow down, and molecules become more tightly bound. So I'm going to put over here, solid to liquid means absorbs heat. And gas to solid means releases heat. And I should probably put up here that it's solid to liquid to gas. Okay. Stored heat and changes of state. When a material is one of the three states, its temperature rises as heat is added to it. If, however, the material is in the process of changing state, its temperature remains the same as it is heated. During the change of state, the added heat energy is not increasing the kinetic energy of the atoms or molecules, and therefore the temperature does not change. The added heat energy is being converted to a kind of potential energy, or stored heat. In order for a change of state from a solid to a liquid, or from a liquid to a gas to occur, the substance must gain heat. When the change of state is from gas to liquid, or from liquid to solid, the substance must lose stored heat. The amount of stored heat gained or lost varies with the particular substance and type of change of state. Stored heat and changes of state of water. Figure 5.7 shows how the temperature of a fixed amount of water changes as it is heated at a constant rate from ice, solid water at 100 degrees Celsius, to gaseous water, water vapor at 200 degrees Celsius. The temperature is plotted against time in minutes, upper scale of the graph, and the corresponding amount of added heat, lower scale of the graph. You can see that the temperature remains constant at 0 degrees Celsius for almost 2 minutes, while the water is changing from the solid state to the liquid state. There is another constant temperature interval of more than 10 minutes at 100 degrees Celsius, while the water is changing from the liquid state to the gaseous phase. The reason for these intervals of constant temperature is that the heat being added at those times is being changed to stored heat, potential energy. To find the amount of energy gained or released by water as it changes state, refer to figure 5.6 or the properties of water in the Earth Science reference tables. Earth's energy supply. The energy for some of the Earth's processes comes from the Earth's interior. However, most of the energy Earth needs comes from the sun's electromagnetic radiation. Solar energy. The sun radiates or gives off, the Earth receives a wide range of electromagnetic energy of various wavelengths. The solar electromagnetic spectrum includes X-rays, ultraviolet rays, visible light, and infrared rays. Of all the types of electromagnetic radiation from the sun, the one with the greatest intensity is visible light. So, greatest intensity of electromagnetic radiation is visible light. Solar energy is produced by nuclear fusion, a process in which the nuclei, centers of atoms, are combined to form larger nuclei, releasing great amounts of energy in the process. Nuclear fusion can only occur under the conditions of very high temperatures and pressure. For example, in the interior of a star. Figure 5.8 illustrates the type of fusion believed to be most common in the sun. A small fraction of the energy produced by nuclear fusion is radiated as electromagnetic energy and received by Earth, thus fueling most Earth processes. Earth's own energy. Heat energy from Earth's interior is converted into mechanical energy from mountain building, volcanic eruptions, plate movements, and other internal movements. Some of this heat remains from when the Earth formed, and some is produced as a result of materials being pulled by gravity towards Earth's center. Probably most of the Earth's interior energy comes from the nuclear decay of radioactive materials within Earth. Nuclear decay, also called nuclear fission or radioactive decay, is the process by which unstable or radioactive atomic nuclei of elements such as uranium and radium split to form lighter elements. In the process, large amounts of energy are released. Nuclear decay is the process employed in the atomic reactors used to produce a portion of the nation's electric supply. Figures 5.9 illustrates the process of nuclear decay. Another source of Earth's energy is the energy created by the impact of meteoroids, asteroids, and comets with Earth's atmosphere and Earth's surface. These impacts continue today, although they are likely not as frequent as in ancient Earth history. There are many other minor sources of Earth's energy, including the gravitational energy of the sun and moon creating the tidal energy of the oceans, and many sources of friction. Review question number 31. At which temperature will ice melt under normal conditions? 1, 0K, 2, 32K, 212K, or 273K? Number 32. The change from the gas or vapor phase to the liquid phase is called evaporation, condensation, precipitation, or transpiration. Number 33. Which diagram correctly shows the processes that change the phases of matter? Number 34. Two identical towels are hanging on a clothesline in the sun. One towel is wet, the other is dry. The wet towel feels much cooler than the dry towel because the 1. Dry towel receives more heat energy from the sun. 2. Dry towel has more room for heat storage than the wet towel. 3. Presence of water in the wet towel requires an additional amount of heat energy to bring about a temperature change. Or 4. Water in the wet towel prevents absorption of heat energy. Number 35. Water loses energy when it changes phase from liquid to solid, solid to liquid, liquid to gas, or solid to gas. Base your answers to questions 36 through 42 on the following graph. The graph shows the temperatures recorded when a sample of water was heated from 100 degrees Celsius to 200 degrees Celsius. The water received the same amount of heat energy every minute. Number 36. For the time on the graph represented by the line from point B to point C, the water was freezing, melting, condensing, or boiling. Number 37. At which point in time would most of the water be in the liquid phase? 1 minute, 14 minutes, 16 minutes, or 4 minutes? Number 38. What is the rate of temperature change between point C and D? 10 degrees Celsius per minute, 25 degrees Celsius per minute, 50 degrees Celsius per minute or 150 degrees Celsius per minute.